This is Franklin Turback, and this series of screencasts is about how to handle fruitful methods in the Java execution model. I'll be using some supplementary slides which are posted on the CS111 schedule page on the Monday, February 11th entry. So here's what we're going to do in the screencast. I'm going to tell you what a fruitful method is. I'm going to tell you how you handle fruitful method invocations in a Java execution model diagram. And then I'm going to show you how you define some simple fruitful methods. And we'll be using these a little bit when we study conditionals in the upcoming week, and then a lot when we study Picture World the following week. Okay, so what exactly is a fruitful method? A fruitful method is any method that, when it is invoked, returns a value. In a contract, a fruitful method is designated by something that has a non-void return type, whereas in contrast, things that have void return types are not fruitful methods. So let's take a look at some examples. Here are some example buggle methods that are fruitful. We have things like getPosition is fruitful because it returns a location. And getColor is fruitful because it returns a color. And isBrushDown is fruitful because it returns a Boolean. Similarly, in the direction contract, opposite. If you ask for the opposite of a direction, you get another direction. If you say toLocation of a direction, you get a location. If you say toString of a direction, you get a string. In the color contract, if you ask a color to have a darker color, you get another color back. If you ask to get the red component, you get an integer back. So all these examples are examples of fruitful methods. Some example of non-fruitful methods, at least in Buggle world, are things like forward. When you go forward, you don't get anything back. That's what the void means. You get nothing back. When you ask things like left or setPosition or setColor or setBrush, you don't get anything back. Now you may notice here that many of the non-fruitful methods have parameters, like when we setPosition, we give it a location, or when we go forward, we give it an integer n. And most of the fruitful methods here, or at least all of them here, do not have any parameters. But that is not essential. That is not an essential distinction between fruitful and non-fruitful methods. There are lots of fruitful methods that take parameters. We don't see any here, but we'll see a lot later in the semester. And there are lots of void methods that don't take any parameters, like left over here. One other thing to note is that when you invoke a fruitful method, that such invocations are expressions. An expression, remember, is any program fragment that returns a value. So because fruitful methods return things, the invocation of a fruitful method is an expression. In contrast, the invocation of a void method is a statement. A statement is something that performs an action without returning a value, and that's what the void indicates. Okay. So many people have asked how you handle the invocation of primitive fruitful methods, things like getPosition and getColor and so on, within the Java execution model. So these are ones for which, when we invoke these methods, we're not going to show the execution frame. We're just going to assume that they happen. And to understand how we do this, let's take a look at a concrete example. So here we have a object land and execution land set up. We have a very simple run method. It just creates a test buggle, which in fact doesn't have any interesting methods as far as we're concerned. And it's just going to do a few manipulations with this test buggle. Okay, so we have in execution land, we have a 5 statements that we're going to execute here. And we're going to start with the first of these statements, which is the assignment statement. So to execute an assignment statement, it consists of 3 parts. We are first going to make a variable, then we're going to evaluate the right-hand side, which is going to create a new buggle, and then we are going to perform the assignment. And when we do those things, what happens? We get the following. So we get in object land, we get a new test buggle over here. And in this particular example, we are going to stress the fact that locations are objects too, so rather than just showing them as ovals with pairs of coordinates, we're going to show them as objects in object land. And remember that all objects have an object identifier in an oval. It's just a name in an oval that uniquely specifies the object. And the ovals distinguish them from the variables, which are names that appear down in execution land that do not have ovals around them. So names without ovals are variables in execution land, and names with ovals are names of objects in object land. So there are two different kinds of names. And we see that the execution of the assignment has created a new variable named tests, and that variable name contains the reference to test bugle TB1, and so that variable box contains that reference value. That means that if we refer to test later, we know what test is. And notice how over here the expression new test bugle has been replaced by the reference TB1. Okay, the next thing we're going to do is we're going to ask test to go forward by 3. So we have to evaluate tests. The value of test is TB1. And then when we ask test to go forward by 3, voila, she moves forward by 3 units, ends up over here. And in object land, it turns out she has now gone to a new position. She's gone to a position 4-1. It turns out these location objects are immutable. They cannot change over time, so we can't just go in and change the x value over here. That's not possible to change the x value, so we have to actually create a brand new location to represent the new spot. And then we show that the new location has replaced the old one because the position variable now contains L2. So the instance variable of test bugle has changed over time. And variable, remember, is something that can vary over time. So it used to be L1. Now it is object reference L2. Okay, so now what are we going to do? We're going to execute the third statement. What is this statement doing? It's an assignment statement in which we are going to create a variable named oldLock. Then we're going to evaluate what's on the right-hand side of this expression. And test.getPosition, what is test's position? It's location L2. So this is going to become the location L2. And then we're going to stuff that L2 into the variable oldLock. So the result of doing that is displayed in this way. Notice that what used to be the getPosition expression has now been in our model replaced by the object reference to L2. Because a fruitful method invocation is an expression that denotes a value. And in the Java execution model, when we evaluate that expression, we show the result of the evaluation, which is the value L2. And notice, too, that names that appear on the left-hand side of an assignment, things like tests and oldLock, they never change. They are names specifying the variables. They're not specifying the values of the variables. So they're specifying the name we are going to give to a brand new variable when we create it. They never change. But if we use those variables elsewhere, those uses will change to be the values of those variables. Okay, and we're going to see an example of that in the very next assignment. So what happens in the next assignment? Let's go through this in detail. It's a very complex thing. So what's the first thing that happens in an assignment? Well, the first thing that happens in an assignment is we're going to create a variable by that name. So in this case, we create a variable called newLock. So let's create it. There it is. It doesn't contain anything yet. It's an empty variable. Next thing we're going to do is evaluate the right-hand side of the assignment. This is an expression. It's an expression that's going to create a new location. And that is a constructor method invocation, and it has arguments. So we have to evaluate the arguments one by one. First, we're going to evaluate the first argument to new location. Well, that has parts. It has a subpart that's oldLock.y, and to evaluate oldLock.y, we have to evaluate oldLock. Now, how do we find the value of oldLock? Well, gosh, the whole reason we have variables in our execution model is so that when we come across a variable, we can just look it up inside our execution frame. So the value of oldLock is simply L2. Now, L2.y, what does that mean? That means to extract the instance variable y from the location L2. What is that? Well, we look up at L2 on object land, and the instance variable y has the value 1. Therefore, L2.y is 1, and we can replace it by 1. And we do. And now we are left with 1 plus 5. The value of 1 plus 5 is 6. Next, we have to evaluate oldLock.x. To do that, we evaluate oldLock. oldLock is still L2. L2.x, we extract the x variable of L2. That is the value 4. We now multiply 2 by 4 to get 8. Now we can see that what we're really asking for on the right-hand side of this assignment is to create a new location whose x-coordinate is 6 and whose y-coordinate is 8. If we create such a location, we have to create a new object in object land. That's sitting right here, object L3, x-coordinate 6, y-coordinate 8. And we denote that down here by replacing the new location constructor method invocation by the value L3 that it resulted in. So that's an expression 2. And the final part of our assignment is to actually perform the assignment, which is to stuff the L3 into the new location. So we're going to stuff this into this location over here. And what do we get as a result of that? We get the L3 in there. And then finally, we are going to set Tess's position to our new location. So first thing we're going to do here is we're going to evaluate the expression Tess. That's going to evaluate to Tess buggle 1, TB1. We're going to evaluate the subexpression new lock, which is going to evaluate to L3. And so we get those two parts. And now we're saying, hey, Tess, or rather, hey, Tess buggle TB1, set your position to L3. And what is that going to do? Well, up here in object land, we're going to change L2 to become L3. And when we perform that, the L2 changes to L3. And also notice that in our grid world, we see the buggle moving over to position 6, 8. And that is the end of the execution. There's nothing left to do.